welcome to Two Projects. In this video, we are going to explain the project Skincare Product Recommendation using Neural Networks. Before diving into the execution, let me give you an overview of the project. So, this project aims to provide personalized skincare recommendations by analyzing skin images. So, it identifies skin type and detects concerns like acne or dryness, then suggests suitable skincare products. Its goal is to make skincare easier and more effective for everyone. So, this is the primary objective. And traditional methods used for skincare product recommendation usually depend on general advice or evaluations by skincare professionals, which might not suit everyone's diverse needs. So, there comes computer vision and deep learning. So, computer vision and deep learning can automate and improve the recommendation process. Deep learning models analyze skin images to classify types like oily or dry, enabling personalized suggestions. Additionally, by training models to detect concerns such as acne or wrinkles, recommendations can be tailored to individual skincare needs. This means the system can analyze skin conditions more accurately and provide personalized skincare solutions for each user. It is a way to make skincare recommendations more precise and tailored to individual needs, ultimately leading to better results and classification for users. So, this is what we are doing in this project. Now, we'll see the workflow. So, the dataset contains pictures labeled with different skin types as well as annotated images highlighting various skin issues like wrinkles and acne. So, models for detection and classification must be trained on these images. So, before training the models, we will be pre processing these images using image data generator techniques. So, we will apply image processing techniques prior to feeding the dataset into deep learning models. These techniques include rescaling for consistency, shear transformation for variability, zooming for scale variation, horizontal flip for orientation diversity, and reshaping for compatibility with model inputs. So we'll do this so that the model will learn the images from different angles and generalize well in all the situations. So after pre-processing, we explore various deep learning techniques, deep learning architectures such as ResNet 50, CNN, Inception V3, DenseNet 201, and Exception for classification to accurately classify skin types based on input images. Additionally, models like YOLO V5, YOLO V6, YOLO V7, and YOLO V8 are trained to detect specific skin concerns within images. So, these models are specifically designed to pinpoint details like acne or wrinkles, allowing the system to provide targeted skin care recommendations based on the detected concerns. Overall, the aim of the project is to create a system that can analyze user provided skin images, identify skin types, detect specific concerns like acne or wrinkles, and then recommend suitable skincare products. So, this system benefits users by providing personalized skincare advice while also benefiting the skincare industry and professionals by enhancing customer satisfaction and improving skincare outcomes. So, this is what happens in this project. Now, we will see the software and hardware requirements. Hardware requirements to execute this project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language needed is Python, front-end framework required is Flask, backend framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we will look at the algorithms built. So in the base paper, author has proposed these three algorithms for classification. And for improved performance, we are proposing DenseNet 201 an exception in this project for classification purpose. So now we'll understand about the DenseNet 201 algorithm. So the project uses DenseNet 201, a neural network used for image analysis, specifically in categorization. Its architecture allows for efficient feature reuse across layers, enhancing learning and performance. DenseNet 201 is used in a transfer learning approach, leveraging pre-trained weights from the ImageNet dataset. This allows the model to recognize a wide range of features and patterns. The model's ability to detect subtle variations in skin characteristics allows for precise classification of different skin types based on input images. And now coming to exception. Exception is a deep learning technique again. It is known for being good at understanding images. It does this by breaking down the process of looking at images into two main steps. First, it looks at different parts of the image separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. So this helps exception to understand images better and pick up on important details. One of its strengths is that it is really efficient at doing this, which is important when you are dealing with lots of images. Plus, it is great at figuring out what features in the images are important for making classifications. Another important thing about exception is that it can learn from other datasets before being used for a specific task. This is called as transfer learning. So this makes it super adaptable and useful for classifying skin cancer classification. So we will be building all these models, the classification models, which are proposed by the author and which we have proposed, and we'll compare their performance to select the best performing one in all the performance metrics, that is accuracy, precision, recall, and F1 score. And we are extending the project by employing detection algorithms for detection task. In detection, will not only classify skin type but also will pinpoint the skin concern, drawing bounding boxes. So these are the algorithms built for detection task. So now we'll understand about them. YOLO, that is You Only Look Once, is a computer vision object detection algorithm that quickly identifies objects in images by splitting the input image into a grid and simultaneously predicting bounding boxes and class probabilities. Unlike traditional methods, YOLO processes the image just once, making it extremely fast. It predicts multiple bounding boxes and their associated class probabilities for each grid cell and then removes redundant detections using non maximum suppression. So, this results in a final list of detected objects along with their bounding boxes and probabilities. So, these are different architectures in YOLO. So, YOLO V5 is known for its balanced performance between accuracy and speed. This version relies on a backbone network called CSP Darknet 53. It utilizes focus modules for downsampling and path aggregation network PAN for feature fusion, enhancing object detection across different scales. Now coming to YOLO V6. So YOLO V6 introduces a key difference by using Efficient Net L2 as its backbone network. Compared to Efficient Net used in YOLO V5, Efficient Net is known for its efficiency with fewer parameters, and YOLO V6 also employs a novel dense anchor box generation method to improve object detection accuracy. And about YOLO V7, it uses a modified version of the Swin transformer architecture as its backbone. This architecture leverages self attention mechanisms, leading to better feature extraction compared to convolutional neural networks used in prior versions. And now coming to YOLO V8, it is the latest version focused on facilitating performance comparisons with older YOLO models. So YOLO V8 also introduces a unique loss function and an anchor-free detection head, which are technical improvements to the overall detection process. So we will be comparing all these models and select the best performing model in the performance metrics, precision recall, and map. So after comparing the models, the classification models and detection models, we have observed that exception model has outperformed all other models in classification, and YOLO V5 has outperformed all other models in detection task. So we will be deploying exception and YOLO V5 into Flask framework. Now we'll see the execution of the project. We will be executing the project using Flask web application. Before that, first we need to open the code folder, which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. So I'm opening data folder in which I have the required skin concerns dataset. So here I have two separate folders for classification and detection. I'm opening classification folder. So we can see I have three classes of skin concerns, acne, spots, and wrinkles, in which I have respective images. I'm opening acne folder. So these are the acne images I have. Similarly, these are spots images I have, and these are wrinkles images I have. So we will be training the deep learning models on these images. Before training the deep learning models, we will split these images, the dataset, into two parts: train and validation sets. So train set is for training the deep learning models and validation set is for evaluating their performance. So after splitting, we have stored the train and validation sets in the output folder here. So we have split the dataset in 80:20 ratio. So now 80% of the images from all the three folders, acne, spots, and wrinkles, are into train set, and 20% of the images of acne, spots, and wrinkles are into validation set. Now coming to detection folder. So here I have different folders for YOLO V5, YOLO V6, and YOLO V7. I'm opening YOLO V5 folder. So here I have train and test. So we have already split the dataset here into train and test. So I'm opening train folder. Here I have two subfolders, images and labels. In images folder, I have acne, spots, and wrinkles images all combined. And in labels folder, I have annotation files. In the same way, I have images and labels folders in V6, YOLO V6 and YOLO V7 folders also. Each folder contains the same images, but they are annotated differently because each YOLO version requires its own specific type of image annotations for training and testing the models effectively. So we will have different annotation files. That is why we have three folders separately: YOLO V5, YOLO V6, and YOLO V7. So now we'll see what are these annotation files. So each label file or annotation file corresponds to an image file in the images folder, providing details about the objects, locations, and classes within the image. So this annotation file corresponds to this image. Similarly, this annotation file corresponds to this image. In the same way, each annotation file corresponds to an image in the images folder. So these label files often follow the YOLO format. So where each line represents a detected object. So we can see in this image there are 6 objects detected. Each line specifies the object's class index. This is the class index. 0 is for acne, and followed by its bounding box coordinates normalized to image dimensions. So these are the bounding box coordinates of the objects detected. So this is x limit, this is y limit, this is width, and this is the height. So in the same way, I have these objects classes, class index followed by its bounding box coordinates normalized to the image dimensions in these files also. So these files correspond to an image in the images folder. Similarly, I have images and labels folder in test folder also. On these images and on these labels, we will evaluate the model's performance, the YOLO model's performance. So this is about the data set. This is sample folder in which I have images again on which will make the classifications and detections. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these are model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And these are Jupyter source files which contain a combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. So this is Jupyter source file for classification, and this is Jupyter source file for detection. And this is signup.db file. This file is the database file used to store user information like signup details. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. So this is the local host and this is the port. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. If we are new users, we have to register ourselves first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the predictions page. So here we can see a prediction link, click on it. As I mentioned earlier, we can perform both classification and detection tasks in this project. First, we'll perform the classification task, click on classification link. So now we have to upload any skin concern image here and the application will classify the skin concern type from the image. Click on choose file button. So from sample images folder, as we are performing classification, from classification folder, first we'll upload any acne image. Click on acne. I'm selecting this image and click on open. The image has been loaded. Now click on upload button. So this is the uploaded image. And here we can see the classification, that is the skin type is classified as acne. So we can see the application has correctly classified it as acne, and scroll down to see the product recommendations. So these are the products recommended by the application to cure acne. So it has given us 6 recommendations. Click on prediction link, click on classification link, click on choose file. This time I'm uploading this image and click on open. The image has been loaded. Now click on upload button. This is the uploaded image, and here we can see the correct classification, that is acne. And scroll down to see the product recommendations. Click on prediction link, click on classification link. This time we'll upload any spots image. So I'm uploading this image and click on open. The image has been loaded. Now click on upload button. This is the uploaded image, and here we can see the classification, that is the skin type is classified as spots. The application has correctly classified it as spots. And here we can see the product recommendations. So with these products, we can cure spots. The application has given us 6 recommendations to cure spots. Click on prediction link, click on classification link, click on choose file. This time we'll upload any wrinkles image. I'm uploading this image and click on open. The image has been loaded. Now click on upload button. This is the uploaded image, and here we can see the classification, that is wrinkles. And here we can see the products recommended to cure wrinkles. So the application has given us 6 recommendations to cure wrinkles. Similarly, we can upload any image from the test cases. So the images of acne, spots, and wrinkles, and can get the classifications of the type of skin concern. And we can get the product recommendations to cure that skin concern. Now we'll perform detection. Click on prediction link, click on detection link. So now we have to upload any skin concern image here, and the application will detect the skin concern from the image. Click on choose file button. So from detection folder in sample folder, as we are performing detection. So these are the test cases I have. We have to choose any image. I'm selecting this image and click on open. The image has been loaded. Now click on upload button. We can see the application has detected acne. It has drawn a bounding box around the detected acne, and here we can see the class label, and we can also see a probability score here telling us the confidence level of this classification as acne. Click on back. We'll try giving another image. Click on choose file button. So this time we'll upload this image and click on open. The image has been loaded. Now click on upload button. So we can see the application has detected the skin concern. It has drawn a bounding box around the detected skin concern. We can see the label, the class label as acne, and we can see the probability scores telling us the confidence level of the classification as acne. Click on back, click on choose file. This time we'll try with this image and click on open. So we can see the application has detected spots It has drawn a bounding box around the detected spots. And we can see the probability score here, telling us the confidence level of the classification that it is a spot. Click on back, click on choose file. We'll try with this image. So we can see the detections here. The bounding box is drawn around the detected spots. We can see the class label and the probability score. This time we'll try with this image. We have loaded the image. Now click on upload button. We can see the application has detected the wrinkles. It has drawn bounding boxes around the detected wrinkles. And we can see the probability score here telling us the confidence level of the classification that these are wrinkles. Click on back, click on choose file, select the image. I am selecting this one. Click on open and click on upload. So we can see the detections here. So here we can see the detections as wrinkles, and here we can also see a detection as spot. Click on back, click on choose file. This time I'm selecting this image and click on open. The image has been loaded. Click on upload. We can see the application has detected the skin concern. It has classified them as acne and spots. And we can see the probability score telling us the confidence level of the classification. We'll try with this image. So we can see the application has detected spots. We can see the bounding boxes drawn, and we can see the probability scores. Similarly, we can upload any image from the test cases and can get the detections and classifications of the skin concern. So we'll try with this image. We can see the application has drawn a bounding box around the detected acne. In this way, we have to upload images and get the classifications and detections. Now we look at the graphs plotted. Click on graphs link. So here we can view all the graphs plotted. This is loss and accuracy curve of exception. This is accuracy scores horizontal bar graph comparing accuracy scores. In this graph on x-axis, I have accuracy scores, and on y-axis, I have algorithm names. Accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. Similarly, this is precision scores comparison graph. Precision is a measure of the correctness of positive predictions made by a classifier. This is recall scores comparison graph. In this graph on x-axis, I have recall scores, and on y-axis, I have algorithm names. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a dataset. This is F1 scores comparison graph. F1 score combines precision and recall into a single metric. It provides a balance between precision and recall, taking into account both false positives and false negatives. So from these classification graphs, we can observe that exception model has outperformed all other models in all the performance metrics. Now coming to detection, this is F1 score confidence curve graph. This is confusion matrix graph. This is precision scores comparison graph. This is recall scores comparison graph, and this is MAP scores comparison graph. So from these graphs, we can observe that YOLO V5 is doing well among all other models in all the performance metrics. Now click on sign out. So Exception and YOLO V5 excelled in classifying and detecting skin types. So we have deployed them in Flask. So this system offers personalized skincare recommendations, and beneficiaries include users for improved skincare outcomes and skincare professionals for enhanced consultations, fostering customer satisfaction and loyalty.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.